So grade now has a challenge. Sucre does not seem to be working that well. So can we come up with something better? Can we provide guidance on how to draw conclusions regarding which treatments are more likely to be superior or inferior to others, considering the estimates of the effect, the quality of the evidence, and the rankings through Sucre, although that's a very secondary consideration because of the limitations that I've described. So we started, some years ago now, we said, we started in the process of coming up with an approach. It took us several years to get to something that we were ready to present to the world. But we started making note of certain principles. Based on our experience, it was very seldom, if ever, that we found an NMA that established a single treatment that was clearly better than all the others. Given that there's seldom a single treatment that is clearly better than all the others, we thought we should consider categories of interventions. Those that are clearly superior, those with intermediate effectiveness, and those that are inferior. The judgments that place the interventions in category will rely on the estimates of effect and the certainty of rating, and only secondarily on Sucre rankings. So the example that I'm going to show you that illustrates the approach that we developed is a network meta-analysis of the interventions for acute diarrhea and gastroenteritis that I've already mentioned. It was published in 2018, and it was the first application of this approach, although it preceded Grade writing it up as a formal methods paper by a couple of years. After we tried it here, we still needed refinements. The population in this network meta-analysis was children with acute diarrhea and gastroenteritis. The interventions comparisons in a network meta-analysis, of course, you don't have one intervention and one comparison, but multiple interventions comparisons, pharmacologic and nutritional interventions, including placebo in some trials and standard treatment without a placebo in others. The main outcome was diarrhea duration in hours. A negative value is good. It means a reduction in the duration. Positive value is not so good. It means an increase in the duration. And we'll need to keep that in mind as we're looking at the results. Here again is what we call the network plot. This describes all of these 27 interventions, 138 studies. The size of the circles indicates how much data is available. The width of the bars connecting the circles indicate how much data is available for those direct comparisons between one treatment and the other. You see by far the single comparison that has most of the data is comparisons with placebo or standard care, although it's a reasonably what we call a well-connected network in that you do have lots of comparisons of one treatment than the other, as well as comparisons with placebo or standard care. So here we have described that, so I'll stop here. Any questions about this particular network meta-analysis that have arisen in the chat?
Okay, so we have
or any other questions that have arisen up to now.
Okay, so just after the first section, we got a question about how does the grade approach align with ideal framework? I don't know if you're familiar with that one.
I'm sad to say you have an ignorant presenter here who doesn't even know what the ideal framework is. So I'm afraid I'm quite hopeless at addressing that question. I hope I do better at some other questions in the future.
Okay, so let's look at the second one. How to look into excess significance bias in a network, or also a pairwise meta-analysis.
Excessive significance. I'm not sure what is meant by that. Personally, maybe what is meant is that you can have a large amount of data with a narrow confidence interval, but the effect is small or trivial. Perhaps that's what's meant by excessive significance. We have lots of statistical power, but the treatment actually isn't very good, a small or even a trivial effect. And the way we do that is, as you will see, we emphasize not only statistical significance or narrow confidence intervals, but also the magnitude of the effects.
Okay, and the final question for this section, is there any website or a tool like Grade Pro for this NMA grade assessment?
There is certainly, you could use Grade Pro or the Magic Making Grade the Irresistible Choice instrument. Magic has a very nice particular application that allows you to take a network meta-analysis and pick any pair of treatments and look at those pair of treatments. It's called the Match It instrument, but it requires you to think about things when you generate the approach that we're talking here. And that's a difference between what we have done and what the Cochrane folk have done. The Cochrane folk have something called Cinema, where you don't have to think so much. You just plug things into their software, and it tells you what the certainty of the evidence is. In the grade approach, you have to think about things more. We think, of course, totally biased, we think that there are very limitations of this mechanistic approach that Cochrane has suggested, and we advocate you use the approach that I'm about to show you, where you have to think about it. Okay, I think we should continue now.
Yeah, we're done.
All right, so there's 5 steps to the approach that I'm going to tell you about. You choose a reference treatment and a decision threshold. You have a first classification on comparison of each intervention with the reference, a second classification based on pairwise comparisons, separation of the 2 main groups according to the quality of the evidence, and then checking the consistency with pairwise comparison and rankings. And I'm going to go through each of those steps, starting with the choice of the reference treatment and the decision threshold. So you want to pick what we call a reference treatment, where your first decision is going to be based on how every other treatment relates to this reference. Well, how should you decide on a reference? The more direct evidence, the more likely it is to be higher quality. So, and it's more appropriate to make conclusions based on higher quality. So you want to pick the intervention, the reference that is most well connected and has most direct estimates. And if there is more than one treatment that is highly connected, you want as much high quality evidence as possible, you'll pick that one. It's very nice if the one that meets these criteria is placebo or standard care. It makes the interpretation easier. And indeed, we're lucky in this case that clearly the reference is going to be placebo or standard care, where you have by far the most evidence comparing each individual other treatment to placebo or standard care. So that's going to be our reference. The next decision you need to make is what we call a decision threshold that represents a reasonable criterion to claim that one treatment is better than another. And we have 2 suggestions. One can be, we're going to conclude that a treatment is better than the reference if chance represents an unlikely explanation. In other words, if the confidence interval excludes the null, which corresponds typically to a p-value of less than 0.05 if you're in a hypothesis testing framework. Or another alternative threshold is that the difference is greater than what you consider the minimally important difference. In other words, the confidence interval excludes not a zero effect, but excludes a minimally important difference. If you're using relative effects, as in all grade ratings, you should be changing that to absolute effects when you consider the minimally important difference. In the original paper in 2018 and in this presentation, I'm going to present it. It was done there, and I'm going to present it here. The excluding chance as the threshold. If you go back to the BMJ paper, you'll see that in that particular presentation, we used a minimally important difference threshold, which we set at 3 hours, a 3-hour reduction in the duration of diarrhea. So now we've decided on a decision threshold, either excluding chance or excluding a minimally important difference, and we make the first classification based on that. So here we have 5 possible results. The first result at the top is one where it overlaps no effect. So, and is clearly does not exceed the minimally important difference represented by the dashed lines. So this treatment is clearly, whatever standard you use, is no better. This treatment is no better than the reference. The second one down would be seen as better than the reference if you use the threshold of no effect, represented by the blue line. If you used our 3-hour threshold, represented by the minimally important difference, the hatched line, you would not be convinced it is better because the confidence interval overlaps that threshold. Here on the other side is something that is using the null is clearly worse than the standard. Using the minimally important harm would not be worse. The next one down, whether you use the null or whether you use the minimally important difference, is clearly better than the reference standard. And the last one is clearly worse than the reference standard. I'm going to pause here. This is crucial that you understand this part. I'm going to pause for a moment to see if there's any questions about this.
We don't have any on this one, this particular section, but if you want to go back to other questions or you want to wait for the final section.
We'll need to move along, but
okay.
Why don't you pick one, Dario, from the previous?
Okay, is there any, sorry, how different are cinema and grade NMA?
The one big difference is that the cinema is mechanized. You put in your judgments about risk of bias and directness and consistency, and it spits out the certainty of the evidence. In the grade approach, you have to think about it, we would say. And our biased view is that this mechanized approach has considerable problems with it. If you had the cinema folks talking to you, I'm sure they would say something different. But the big thing is a mechanized approach versus one that requires you to think about what you're doing. Okay. All right, so continuing with our approach. So our first classification is based on comparison with the reference. You look at the confidence interval. So for instance, Cowlin-Pectin versus placebo, point estimate, it reduces diarrhea by 5 hours and a bit, and it may reduce it by 33 hours. Unfortunately, it may increase the duration of diarrhea by 22 hours. Clearly, we are not confident that the Cowlin-Pectin is different from the reference because it may be beneficial or it may be harmful. On the other hand, consider symbiotics versus placebo. Our point estimate is a 26-hour reduction in the duration of diarrhea, it might be as much as 36 hours or as little as 16 hours. No question, symbiotics appear better than placebo. We're going to call interventions that are better than placebo category 1 interventions. So what happens when we applied this? We had a whole bunch of these 27 treatments that were not convincingly different from placebo. The confidence interval overlapped our threshold. But we had a number of category 1 that were better than placebo or standard care, in that the confidence interval did not overlap our threshold. So we have now 2 categories, but we want to go further. We want to see if we can find a 3rd category that is better than the other treatments in category 1. And that's based on pairwise comparisons between the treatments in category 1. So here you have category 1. We've already established these are better than placebo or standard care. Now, is anyone better than the other? So we do every paired comparison. And for example, if we pick all probiotics versus another treatment that I find hard to pronounce, you see the confidence interval includes a 10-hour reduction in with probiotics, but it also includes a 6-hour increase. Clearly, probiotics are not convincingly different than the other treatment. They stay with respect to that in category 1. Zinc plus probiotics versus zinc. If you use a threshold of the confidence interval not overlapping no effect, a almost 11-hour point estimated reduction in diarrhea up to 20, down to a very short reduction, but it excludes no difference. So zinc plus probiotics would move up. Very wide confidence interval with benefit and harm. Zinc plus micronutrient versus zinc stays in the same group. The next one has a confidence interval that excludes no effect, and it will move up. And as it turns out, there are 4 treatments that are better than at least one other treatment in category 1, and it moves to category 2, the superior treatments. Here now comes the grade special contribution, the quality or certainty of the evidence. And that was one of the key problems with Sucre, is it didn't consider quality or certainty of the evidence. Here, we divide the treatments into 2 categories, those for which we have high or moderate certainty against the reference, and those which we have low or very low certainty. So, as it turns out, there's only those not different from placebo, almost all low or very low certainty. Category 1 divided by those in green in moderate or high certainty, and those with low or very low. And then finally, category 2, the ones with at least one treatment better than category 1, 2 of them high, 2 of them low. We then check consistency with the pairwise comparisons and the rankings. And as it turns out, I'm not going to spend much time on this. And the reason I'm not going to spend much time is we've never had a problem yet with problems when we check its consistency with pairwise comparisons and rankings. This seems to be robust to that issue. We've done quite a few of these now, never been a problem. My prediction is that this step is going to very seldom, if ever, going to cause inconsistencies that are a problem. So here's the final output of this whole exercise. In green, you see high or moderate certainty. You see 2 treatments that are in category 2 among the most effective because they were better than at least one treatment in category 1. Category 0 among the least effective. You similarly have those most effective, intermediate, or least effective, but where you only have low or very low certainty evidence. So if you are the clinician now, probably you are thinking of using one of those that are among the most effective. And if you have a high respect for having high or moderate certainty of evidence, you're going to choose one of the two for which you have high or moderate certainty evidence, even though the biggest absolute effect with a nice narrow confidence interval is for the LGG plus smectite, but unfortunately only low or very low quality evidence for that particular comparison. Okay, so there we have got to a bottom line about the categorizing the treatments, which was the objective of the whole exercise. Questions or comments at this point?
We do have a general question about the validity of NMA. So we can take it either later on or now, how you want to.
Okay, let's keep going, and we'll have make sure we have time for questions at the very end. What about harms? For harms, it's the same process, but an opposite rating. The best treatment would be no worse than the reference if it's placebo or standard care. And if it's an alternative treatment, the best could be less harms than the reference. But placebo or standard care, you don't expect any harms, so the best would be no worse than the reference. Inferior to the best, but not worse, would be more harms than the reference. That would be category 1. And the worst would be more harms than those in category 1. Just a sort of mirror image of the, when you're looking at benefits, where the best is no different, the intermediate is better than the placebo or standard care, and the best is something that's better than at least one category 1 intervention. Well, what happens now? We focused the whole discussion up to now has been on a single outcome. What if there were multiple outcomes? And we decided we needed a way to present multiple outcomes, and we had some ideas, but we wanted to test them. We created a steering committee that oversaw the process. We chose a network meta-analysis that had variable certainty, variable magnitude, included both benefits and harms, included both continuous and binary outcomes, at a minimum of 5 interventions and 5 outcomes. It turned out that something that met all these categories was a network meta-analysis that our group had undertaken, looking at the treatments for acute musculoskeletal injuries in patients presenting to the emergency room. We developed 2 possible formats, got a lot of feedback, first in large groups and then in one-to-one interviews, and made iterative changes on the basis of feedback, and ended up with 2 approaches. One approach with higher moderate certainty evidence says among the best in the dark green, intermediate, lighter green, among the worst, a very light green. That's in the high to moderate certainty evidence. The lower, very low certainty evidence, everything's in gray. In adverse events, everything is in red. And the worst is the deepest red, the intermediate less deep, the no more harmful than placebo in the lowest, in the lightest red. And the lower very low certainty is in gray again. And here's what you end up seeing. So if you see topical NSAIDs among the best in terms of 5 different outcomes of importance and benefit, and no, not a big problem in any of the adverse effects. Oral NSAIDs better, but one intermediate red for us concern about harm, and perhaps not quite convincing. And I think the only three we might consider are the first three, I suppose, 4 and 5, but not, my goodness, the topical NSAID certainly stands out, and you're certainly not going to use one of the ones for which there is only low or very low certainty evidence, particularly if the ones that included the opioids, where you had harms as shown by the bright red. An alternative was what we think of as fully a stoplight approach. This is a second way of presenting it, where it's the green is better than placebo and some alternatives among the best in the high quality evidence. The intermediate is yellow, and among the worst is red, way stoplights work. Similarly, adverse events, no more harm than placebo is green, yellow is intermediate, red is not so good, among the worst. And the lower, very low certainty stays in the same gray colors. And here's what this looks like. And it sort of jumps out at you now that topical NSAIDs look better, not only in benefits, but also with respect to harms. And you see some of the harm of the ones that are not so good in terms of benefits now hit your eye much more than they did previously. So last of our questions, this is approach 1, where the greens are all the benefits and the harms are all in red. This is approach 2 with a stoplight approach, where you have green, yellow, and red for the benefits and the harms with the high and moderate certainty evidence. What preferences from what you've seen, you haven't had much time to think about it, the people who participated in our studies. Oh, and by the way, I should have said, these two approaches were split. The people who responded, some of them did approach 1 that looked like this. Some of them did a preferred approach 2. There was no clear consensus. These were the best 2, but they split. So the people who participated had much more time to think about it than you do. But on first off-the-cuff reactions, who would prefer approach 1 that looks like this? Who would prefer the stoplight approach, approach 2?
Sorry, Gordon, I don't think we have a poll for that.
Ah, too bad.
Too bad.
No doubt I messed up. I intended to have a poll. So I'll just tell you my opinion. I like the stoplight. To me, you have to look more carefully at this one than you do at this one. And here, I like it that whether it's benefits or harms, the green is good, the yellow is intermediate, the red is bad on both the benefits and harm side. The only counterintuitive thing perhaps is that the red you think is really bad. Well, it's not really bad, it's just no better than placebo or standard care. Anyway, those are the 2 approaches that we are suggesting when you have multiple outcomes. And the point of this, of course, is that you can apply the approach that I showed for benefits in diarrhea to either to one outcome, and you can do it on every outcome that is included in the network meta-analysis, and then present the results across outcomes in this sort of presentation. So, bottom line, if there are multiple treatments, it's very hard to decide in league tables, and it's worse when you have multiple outcomes. So how do we solve it? Sucra has been suggested. We think it's a bad solution. It has problems with precision, with judging the magnitude of effect, and it leaves out considerations of certainty or quality of evidence, which we think are crucial. Grade approach that I've shown you classifies treatments among the best, intermediate, and among the worst. It starts with a focus on the reference, but it also includes issues of comparison of intervention to one intervention to another in moving from category 1 to category 2. The threshold for a difference from the reference or one another is either the null, excluding chance, or the minimally important difference. And we've done extensive user testing on presentation formats for multiple outcomes. Okay, 6 minutes left according to my clock for any questions that people have offered.
We have just a couple of questions which are more, I would say, general, at least for now. Maybe we will receive some more. So I would start with this one about, do you think the validity of NMA is well established? If so, which studies were most influential or more influential to show it?
I am very biased. I've obviously been part of developing Grade's approach to network meta-analysis, and we've done quite a few network meta-analyses ourselves. But if you'd asked me 5 years ago, I would say, oh, no, we still didn't have a great approach, and the methods work has been limited. In the last decade, there's been a lot of work, and it's accelerated in the last 5 years. So we now think we have a very sophisticated way of looking at certainty of evidence using Grade. You've seen we think, a sophisticated way of deciding which treatments are best, intermediate, or the worst. The statistical, I told you that Romina has been leading a number of papers to refine the Grade approach. We've identified all sorts of problems, heads up, and we've identified solutions to those problems. So I would argue it is now a pretty mature methodology that yields trustworthy results when, as in any meta-analysis, it's done right.
Okay, we have now a couple more questions, so we perhaps can just quickly go through them. Should one present direct, indirect, and network estimates in one table in NMA?
I argue yes. For many instances, it's going to be a table in the appendix. It can be overwhelming as league tables, other ways of presenting. Network meta-analyses can be overwhelming. You should be able to find it somewhere. For each outcome, for each paired comparison, somewhere you should be able to find what happened with the direct, what happened with the indirect, and what happened with the network. We think that it's potentially very informative to know this. So although it may be too much for most readers or most users of the network meta-analysis, it should be somewhere, if nowhere else, in an appendix.
Okay, and then perhaps a related question, should the results from NMAs have different presentations to laypersons or researchers or clinicians?
Well, the answer is yes, there should be different presentations. Well, I'll step back. It's just like a conventional meta-analysis. Most clinicians are not going to be able to have a sophisticated understanding of the methods. But one interesting thing that I found is that 10 years ago, when I was presenting to clinical audiences, I showed a forest plot, I had to explain it. Nowadays, all over the world, I show a forest plot and ask people who are familiar with this sort of presentation, and almost every clinician puts up their hand. So it's really the education in some of the basics has proceeded. But ultimately, I'm going to go back. Ultimately, this is what I expect clinicians to look at. So you want all sorts of details in the NMA, like we just said, the direct, indirect, and network estimates somewhere for people who are interested in that. But for everybody, you need a simple presentation like this. So the idea is to, when you're publishing a meta-analysis, you focus on the key points and direct the clinician audience to those key points, which I think are captured in this table for a network meta-analysis, as well as including the information for more sophisticated audiences.
Okay, perhaps just two quick questions for the end. What is opinion about the use of fixed effects versus random effects to reduce confidence interval in NMA? Is it fair?
The fixed and random effects have, in any situation, network or conventional pairwise meta-analysis have strengths and weaknesses. They have their advocates. Each one has their advocates. But my take, after thinking about it for a decade or two, is that each has its strength and each has its weaknesses. At the moment, we start with random effects, typically in the network, but with poorly connected sparse data networks, random effects sometimes yields completely counterintuitive results. And then we switch to a fixed effects model. And I write my protocols now saying, we're going to start with random effects, but we know we might see real problems, in which case we're going to switch to fixed effects, which generally solve the problems. And one of Ramina's papers about the NMA approach shows how the fixed effect can solve counterintuitive results that come from random effects. Here's what I wanted to show for anybody. I'm advertising my my Twitter. So anybody who wants to keep up to what I think is going on in network meta-analysis and other aspects of evidence-based medicine, there's my Twitter feed.